Hey guys, and welcome to episode 2 of my Vinia series. Um, if you watched the first episode where we were installing and going over the basics of a Vinia, you know that I told you that if you didn't understand the imports or the classes or the inheritance or anything like that, to just not worry about it because I was going to do an episode to go over that. So that's what this episode is. This episode is essentially a Python primer, but the Python features that are covered are focused on things that you will see a lot in NVIDIA. So if you're on Windows, you should have a thing called idle, IDLE, which is a Python interpreter. Python itself is an interpreter because it's an interpreted language. So if you type Python or open up idle, you'll be typing directly into the Python interpreter. I'm not going to use the default one. I'm going to use something called IPython just because it works better. I do still have my cold from the first episode, so I'll probably be clearing my throat a lot and perhaps sniffing or some other things. So, uh, sometimes we get people in the Avinia IRC channel that are trying to code features, but they do not know anything about data or core Python library or object-oriented principles or anything. So essentially you have someone with zero programming experience that is trying to problem solve with a programming language that they know nothing about. And needless to say that that is problematic and it does not get them very far. Fortunately, Python is a fairly easy language, but we'll try to solve that problem here. So Python can do just basic arithmetic. 1 plus 1 underscore holds the value of what was returned last. So 1 plus 1 is 2 underscore returns 2. Um, and of course, this works for 2 to the 3, 2 to the third power, um, cube 2, um, just write an equation in there. So then you have expressions where you can assign variables, x equals 1. So now we can um, x plus 1 equals 2. So this is pretty self-explanatory, but you can do it. As far as assigning variables, Python is a dynamically typed language. And what that means is that where I just assigned x to be 1, x does have a type. It's a type of integer. I can change it to hello, and now it's a type string. In a strongly typed language, like C or Java, you would have to say int x equals 2, and then if you tried to do x equals hello, you would actually get an error because it would say that you cannot assign a string to an integer. But Python does not require you to declare a variable like that. That can be good and bad. It's good because it makes the language easier to use. It's easier to handle data. It can be bad because as a novice programmer, you may not know what your data is, and so you could make some poor decisions, or you could feed, you could feed a method, a variable that you think is one data type, but it's really another, and you can end up in some errors. So if you imagine, say, a calculator is going to want two numbers. If you try to send it a string or a list or something like that, it's not going to know what to do with it, so you're probably going to get an error. And so that can happen to you sometimes if you're not aware of your data. So let's see, we know what an integer is and we know what a string is. There are a couple of others that are sort of bread and butter. You have true, and the type of true is a Boolean. The type of false is also a Boolean. You'll notice that 0 and false are the same thing, just like 1 and true are the same thing. However, it's best practice to use true and false and not 0 and 1 for when you want specifically a true-false value. um, so that's pretty much the basics of that. You also have a none type none, and none type. So you can basically declare a variable and say x equals none. X returns nothing. Type is none type. None is nothing. It's like null in other languages. 0 is not nothing. And so it just kind of helps you put a variable up somewhere while you're declaring variables and just assign it to none if you want it to be on something, but you don't want it to have any value yet. Maybe it's going to be assigned a value later. So none is also useful. So integer, string, boolean, and none. Fairly easy, and you see here that the type function or type method is always around to help you out to figure out what type something is. So type is actually a method. You can recognize a method because it usually has a name and then these two parentheses. So then we put something in, we put in an argument. So we're feeding it x and it's returning something. So we can write our own method. We could say def add. And so we need to put arguments in here. If we're adding, we need to add at least two things, right? So we'll say def add xy colon, and then return x plus y. So that return is going to add the two arguments that come in. So let's say print add 2, 2, and we get 4. So that just put this 2 here, this 2 here, and then returned them of 2 plus 2, and so we got 4. And print causes whatever was returned to output. We could also do this, x add 2, 2, and then print out x. And so that return can be assigned to something, or you can print it. If you just, in the interpreter, you'll see it print return, but in if you are actually writing a file and you did not capture the data that it returns somehow, it's just going to go nowhere. So that's how you write a method. That's a very basic method, but that gets you the idea of define, method, arguments, return a value. Obviously, sometimes you'll want to do a lot more calculation or logic in a method and then return something. Like for example, let's make title string, return string title. So then let's call make title hello I love you, which is a Doors song. And see, we get a string that looks nice. So yeah, that's making a method. So let's move on, and I'll show you two more data types. I'll show you a list and a dictionary, and a couple of pretty interesting things that you can do with those. So let's make a list. Let's just say, I'll say 1, hello, true, and none. A list can hold any piece of data that you would like. A list could even hold a method call. It could hold an instance of a class, which I'll show you in a bit. It can hold whatever you want to put in there. Sometimes it's not such a good practice to put some things in a list, but yeah, you can put whatever you want in there. That's your decision to make. So as far as a list, we can now append things to it. Like we can append Griach and see it adds it. We can check out the length of L. Shows 5. We can also get the indexes. So we could do L index hello, and it'll tell us that that's at an index of 1. We can also look up by index with these little brackets. So L bracket 1 bracket gives us hello. So if you want to print all that out, there's also enumerate. Enumerate L. This will actually just return an enumeration object. So you see this here is a memory address. So an object was returned by this method, and it's just saying there is an enumerate at this memory address on your computer. So if we want to actually see that, we need to wrap it up in a list. So list enumerate L, and we see index, we see the index and its value. So index 1, hello, index 2, true, index 3, none, index 4, Griach, etc. So again, if we were to do L index 0, we would get 1. If we did L index 4, we get Griach. Now notice that the indexes start at 0 and the length is 5. So the last index is 4, but the length is 5. So length starts counting at 1 and the index starts counting at 0. And that can be problematic. Sometimes you'll have to, add or remove 1 when you're iterating over a list. You can also take care of that with something like this. Enumerate takes an argument called start, and you can say start equals 1. And now you see we're going 1 through 5, which would be the same thing that len would do. So there's a whole lot of things that you can do. You could pop out 2, index 2, which is going to be true, and so that's why we returned 2. You'll also notice that true is no longer in the list. So our list is back down to 4 elements. So there's pop, append. You can also insert, which puts something wherever you tell it to. Extend. You can read the Python documentation. Let's see. Python data structures. If you go here, this tells you all about data structures. It even tells you about some more advanced usages. You can read through all of this. I would actually recommend it. You notice that docs Python 2 tutorial. You could start at the beginning of the tutorial and just kind of read through the things that interest you. All of this stuff is really good information for learning what you're doing as far as handling data. So that's lists. Let's move on to dictionaries. A dictionary essentially looks like a JSON object a little bit. It has little curly braces around it. It has a key, and then it has a value. So you see that just returned the object back to me. So I could say D equals key value. Now, check the type of D. It returns dictionary. I can also create one like this. D equals dict, and you see it was an empty. That's the exact same as if I did this. You can actually feed that. You can say D dict. Let's see. 0, 1, 1, hello. Give it an enumerated list. And now you see 0 is 1, 1 is hello. And then we can check D0, D1. But you can also have, if we go back to the key value example, you can also have D key. So you have more flexibility on what this index is that you control. So this is really good if you want to have data that you label. So let's say stats, for example. Strength, 12, dexterity, 11. So now let's look up strength. And we get 12. So it's really nice for something like that if you want to label information. You could do something like this, turn that into a list. And so those are the same values, but we don't necessarily know what they're for. There are ways around that, of course, but there's just not. It's just, you would basically just be recreating the functionality of a dict if you did that. So see, I can recreate it there and say D equals dict zip stats lstats, and I've recreated the same thing. So that's a dictionary. It's basically good for labeling information. If you don't need to have keys to search through, if you don't need to have keys, or you could think of them as labels, then you could probably get away with a list. Now there are certain instances where, like, if you want a queue that there are things that you can do that. You can, from collections, import DQ. And so you could have 1, 2, 3, 4 as a list. And then you could actually say list equals DQ list. And then type of L turns into a collections DQ. So a DQ is just, it's a list that has been optimized for taking information off of either side. A regular list is only optimized for adding information and taking off of a particular side, that is the right side. So you can basically expand it, but it doesn't do so well of taking values off the top. And that's what DQ fixes. It's just optimized for pulling data out from wherever you want it. And so that's similar to a list. From collections, there's a lot of pieces of data in here. I won't go into all of them by any means. You have counters, you have an iterable, you have mappings, you have an ordered dict, you have immutable and mutable data, which just means can it be changed or not. So for example, tuple is 1, 2, 3. Well, that's not, I named a variable a data type. So let's say t equals 1, 2, 3. Type t is a tuple. So let's get t index 0, which will return 1. But now let's try to assign it to be 2. It won't let us. Tuple object does not support item assignment. So if I want to redefine that, I actually just need to redefine it. Or if I wanted index 0 to be 2, there, now it is. So I just redefine it. That's an immutable property. So it won't let you change its values. It is what it is. List and dictionary are perfectly mutable, and you can change them. Ordered dictionary is mutable as well. All of them are iterable. You can go over them. So for example, let's see what L is put to right now. Let's go back to this. 1, 2, 3, 4. Let's say for element in list, print element. 1, 2, 3, 4. So I passed over it. Let's say what is each value squared? 1, 4, 9, 16. So you can do whatever you would like with each element in there and just iterate over them. Let's see. I think that's probably enough about data types. I also showed you creating a method. There's some other things. I mean, you throw lists around a lot, like in all, for example. All sees if everything within a list that you pass to it is true. So in here we have a list. We're passing that list as an argument to the all method. Each element in the list is true, so all returns true. If you put a false in there, it will return false. So you could do something like check if x is prime by saying return a is greater than 1, because a prime number has to be greater than 1, and that's how you combine. You have and, or, you can combine those. And all, let's say a modulus I for I in x range, start at 2, go to a. I think that's right. So now let's see, if we pass it 7, it should return true. Oh, I used a and I put x. This this variable right here has to match what you use within. That's its scope. This a is local to this method declaration. So a means nothing as soon as I get out of this method. So let's try that again. Prime 7 returns true. Prime 2 returns true. And so that's interesting. You can also filter. So let's do L equals range. Let's go from 2 to 100. Range will return a list. X range just does a sequence. So it'll go over all of the numbers, but it's not saving anything to memory. So now we see we have a big list from 1 to 100. We can filter with the prime method that list. It will return a list that is only prime numbers. So that's pretty neat. So yeah, we can move on now. I'm going to show you guys classes, and classes will really kind of tie a bunch of these concepts together. So I'm going to quit out of here. I'm going to go to code EvCast. I will make dir randomness, cd randomness, and I will open up something called demo.py. So over here, you start a class with the word class. That's a little big. Okay. Class. So let's make a class called item. Now we're going to have the parentheses here, just like we do with a method definition, where arguments would go. Except here, I guess you could call this an argument, but the argument that you're going to pass to a class is what this class is inheriting from. So you may think it's a top-level class, so it inherits from nothing. You can do that, and that's what's called an old-style class in Python. Most people use new-style classes now, which is going to inherit from object. This is just an object that exists within Python that you're inheriting from. So item is an object, but we're going to add functionality to it. Notice the lowercase o. In EvCast, there is an uppercase O object for game objects, but this is a lowercase o for Python classes. Now we define a method here, which you guys are familiar with by now. So anything with underscore, 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 underscore on each end is like a magic method. This is something that Python knows what it is. So initialization, init, is called whenever something is instantiated, and I'll show you guys that in a second. So we pass it in self, and self is a reference to itself. It's like this in C++, if you're familiar with that, or also Java. So we pass in itself as an argument. That's always the first argument for a method within a class that is an instance method. So most of the time, self is going to be here. So I'm just going to pass right now, and that means just do nothing. So let's create a weapon here that will inherit from item. Def init self. Let's pass. And let's do, let's make armor as well. But let's make it inherit from item. And you see there that this put a super in. I let my editor build a class for me, and it automatically assumes that I want to super. And we'll go into that in a second. And then let's do class shield. For now, we'll just leave this like that, which this won't run because that's bad syntax, but I'm going to show you guys something else with that in a second. So we've got these classes. Weapon and armor are both items. So let's say print in item init. And so if weapon and armor are both items, that means they will have whatever item has. So item at the root, this is a design decision. Item at the root will need to have things that are common to everyone. So let's say self.value equals 100. Self.weight equals 0. So value and weight seem like pretty proper things for every type of object to have. So weapon and armor will both have weight and both have value. So let's think of something specific to weapon here. We'll do damage. And for armor, we will do armor class. And so I'm just hard coding values in here. Now this super that you see, I'm going to add it to weapon as well. And then I'll explain what it's doing. So what this is doing, here I'll get rid of shield for a second so we can run this. If we run it right now, you'll notice that, oh, I didn't save. Nothing happens because it's just a bunch of class definitions. We haven't instantiated them. So let's show an instantiation. I equals item. You see in item init. So we instantiated this. This is going to return a new item and place it in I. So went to item, this ran because Python automatically runs this if you define it when this class is instantiated. So that's why we see this. That means I will also have a value and a weight. Print I value, print I weight. So we should see that 100 and 0, just like we set up here. We can also change these. These are known as properties. So we can say I.value equals 200. We can say I.weight equals 3. And then print out I.value again, print out I.weight. 203. See? So these are called properties, and you define them. Now, if I had two items, let's make another one up here. When I was referring to these as instance variables, the self refers to this instantiation of a class. So I has its own thing. Down here, let's set IT value equals 300 and IT weight equals 2. And then print IT value, print IT weight. You say we have 300 and 2. So IT and I are completely separate items that have their own properties. You can make class properties and class methods, and those remain static across every instance, and you don't even have to instantiate a class to use a class method, but you can Google that if you would like. So I'm going to show you now how super works. I'm going to add some statements in here so we can see where the flow of the program is going. So let's say print in weapon, print in armor. And now let's say print assigning damage, print assigning armor class. So now watch what happens if I create a piece of armor. See in armor, in item init, assigning armor class. So just to be extra clear up here, assigning value and weight. Let's see it again. So what we're doing is it's hitting armor, it's hitting this, it's hitting this. So then we see what this does. Super armor, that's the class here. Self, that's this instance of it. So the super of this class in this instance, which it's going to go up the chain. It's seeing what we're inheriting from. So you could also just read this piece as item. So item, execute init. So we're going to item and executing init. That's why we're printing in armor first. And then you see in item init, assigning value and weight, assigning armor class. So now let me show you a little more complex of an example. A shield is a piece of armor because it protects you. It's also a weapon because you can do like shield bash, for example. So we may want a piece of data that combines two other pieces of data. So let's do initialization here. Print in shield. And let's just call super here because shield isn't going to have anything special about it other than it is a combination of weapon and armor. You don't want to make a class unless functionality changes. For example, if I want to say class axe inherits from weapon, def init self, self.damage equals 10. And now let's say class sword weapon, def init self, self damage equals 8. So I say I want my swords to start out with a base of 8 damage. I want my axes to start out with a base of 10 damage. This is not the best practice because you're creating classes kind of for no reason. A weapon has damage all by itself, And so you can just create a weapon and change its damage property. You don't need to create a new class just for a variation. A new class should always have different functionality. So let's say you want an axe to be able to chop and pass it an argument that we'll call thing. And so we'll say print I am chopping and pass it whatever the value of thing is. Now axe is a valid class to inherit from weapon because a regular weapon can't chop. A regular weapon does not assume what type it is. So a sword may slash. Self thing. I am slashing thing. Alright, so now a sword slashes and an axe chops. That's different functionality. So now this is okay. The way we had it before, it doesn't need to be new classes. So that's just something to consider. Of keep the amount of classes that you have to a minimum. As much as you can, you know, to have a good design. You don't need to create 1,000 classes that are all basically the same thing. There's a technique called abstraction that I won't really go into, but it just means creating a class that can be morphed in such a way that it can fit many applications, rather than creating a class in such a way that it very specifically fits one application. So then if you need to have 100 similar things, you don't want to write 100 classes. You want to write one class that can do 100 different applications. Maybe that makes sense. So anyhow, shield is inheriting from armor and weapon. So we're in shield. Shield just gets super. So we'll see what happens here. I need to instantiate shield. S equals shield. Sure, I went on a huge rabbit trail. Now we'll run Python. Super object has no attribute shield in it. Did I mess something up? Yes, I did. I'm missing an underscore. Okay, so we're in shield. Then you see we're in armor. Then we're in weapon. Then we're in item. Then we assign value and weight. Then we assign damage. Then we assign armor class. So this is something that Python does called MRO, which means method resolution order. It's an algorithm that is performed within Python that when you call super, as you know, super reads what you're inheriting from, and it decides what order these methods need to be run in. So essentially what's happening here is it's starting in shield, it's going to armor or weapon, and then we're ending it up in item. So it's finding its way up, and then it's cascading back down. So if you've ever written something that does path finding, it can find a path, and then once it gets to the end of that path, it's going to start at the root and come back down. So that's exactly what's happening there. There are more complex examples, but you don't really have to worry about it because MRO will always take care of that for you. You just have to make sure that your classes can actually work together. So we've covered types, being aware of your data. We've covered how to create a method, at least a basic method that takes a couple of arguments. The interpreter, you know some data types. You know how to work with lists and dictionaries, and you will see those all over the place. This class inheritance and super, you will see it a ton in EvCast. And we can go into that when we actually start building in EvCast. We'll take a little bit of a dive into the code base a little bit. But for the moment, I believe this is all I have for you. And so we can call it a day on running through a primer of Python. Hopefully with this information you can play around a little bit. You can go and read a little bit through the Python tutorial. You can play with a couple of those methods that I was showing you, like range and xrange. There are plenty of other methods I also did zip, and I did not even explain it. Um, so just go out to the Python tutorial, play with a couple of methods, play with some data, try to build a couple of things. Create a class, add some more methods. Like let's say you could have a break method. Break is not a good. Let's see. Get broken. Break is a keyword in Python, so you can't name a method after it. And so what happens when an item breaks? Maybe you just print out, I got broken. And so now if we um, always put the parentheses on there. I got broken. So see, this inheritance will carry definitions with us as well. And then we can override them. Get broken. So if I define that down here as well, if I just pass, I got broken shouldn't show up, because what we did is we overloaded or overrode this that we inherited, and we just said pass. Now if we do super, and then we call get broken, we should see I got broken again, because we're calling this code here, and then we're passing. If you don't ever super, you won't call the method that you're inheriting from, and so you just override it completely. And so you could say, I can't get broken, I'm a shield. But weapon and armor could still get broken. So if we, for example, did A equals armor, A dot get broken. You see, I got broken, I can't get broken, I'm a shield. And you can see how we went through the classes there. So that's overloading, and that is also a staple of EvCast. So now I really believe that that's all I have for you. So go and play around, play with some code. Keep in mind that this is just straight up Python, but you'll notice that the EvCast code looks very similar to just vanilla Python. All that's provided for you essentially is a bunch of classes for you to inherit from. That's all that's going on in EvCast. So once you understand those concepts, you can wrap your head around EvCast and use it much more effectively. So next time we will actually be diving in, but until then,